Without further delay, I will go ahead and introduce our first speaker. We're going to talk about, and I love this, how y'all have it. Let's heat up for net zero by 2050. Let's heat up and really just get started, kick this off with Naomi Jabbari. She is going to talk about decarbonization and heat transfer. That's definitely where her background is. She's a mechanical engineer with a master's in science and energy from Texas A&M University. Go Aggies. Recently watched them play some excellent basketball. But she has 15 years experience in the oil and gas industry and energy transition. And she is really passionate about net zero. And I've seen her as part of the chairman for the Net Zero Forum at Valve World Americas. She's also done a lot of great work, a lot of different conferences, but her interest is really around that heat transfer and process technologies for the oil and gas and clean energy, such as hydrogen production, carbon capture technology, and biofuels for the sustainable energy production to reach net zero by 2050. So without further delay, Naomi, take it away.
Good morning, everyone. I'm super excited to start this sustainability summit with net zero by 2050. So I want to share my screen and you can see my slides. And we can go over there.
Okay. I'll let you know when we can see them.
Yeah. So do you see my screen?
Not yet. I still see you.
See me. Give me a few more seconds.
Welcome, Ahmed. I see you. I'm so glad. Thank you for being here early. For everyone who was early, thank you for that. We were just, checking to make sure everything was working, giving you a little me time before we got started. All right, Naomi, we can see you. Take it away.
Okay, perfect. So you see the black screen with net zero by 2050. So thank you, Charlie, for introducing me. My name is Naomi Jabbari. I'm mechanical engineer. I have Master of Science and Energy. And a few years ago, I asked myself how I could use my heat transfer knowledge differently differently to learn more about the new topics in the energy market. And that's when my interest in climate change and the sustainability grew. And I focused on economics, policy, law, and process technologies for energy, including carbon capture, biofuel, and hydrogen production. And my background in heat transfer drove me to explore these energy topics further, especially the relation to the larger climate change conversations. So during this presentation, I will try to talk about net zero. And because I see everyone's life, professional life in energy market is changing due to energy transition. And we see hydrogen, carbon capture, and biofuel projects are growing every year. And electrification is changing everyone's professional life and our traditional energy market quickly. I will try to reply 3 main questions today. What is net zero and why is net zero important, and how to achieve net zero. I'm sorry, there's a noise in the background.
Okay, I'll try to fix that for you.
Oh, okay. So the main reason for all changes in the energy market is global warming. Greenhouse gas effect was discovered in 1824 by French scientist Joseph Fourier, and we know atmosphere passes visible light and traps infrared. CO2 and other greenhouse gases trap heat in the Earth's atmosphere. And nature's carbon cycle normally keeps CO2 level in balance, but human activities, mostly the burning of fossil fuels, produce more CO2 than the atmosphere and oceans can absorb. In 1988, UN Intergovernmental Panel on Climate Change, IPCC, formed to study human activity in climate change. Social cost of climate change is too high. So it is important to have climate models and predict the temperature increase for the future. Thanks to heat transfer, thermodynamic, and fluid mechanics sciences, climate models have been developed based on principles for conservation of energy, conservation of mass, and conservation of momentum. Data science and technology improvement help to improve the climate models every year. In 2014, IPCC introduced representative concentration pathways, RCP, describing different levels of greenhouse gases that might occur in the future to predict global temperature increase by the end of 21st century. It was the first shock to everyone about global warming impact. In the Paris Agreement, for first time, countries agreed to work together to limit global warming to well below 2 degrees, and sustainable development scenarios were developed to reach the goals. In November 2021, with COP26, energy transition and climate change discussions continued about limiting global warming to 1.5 degrees based on net zero emission pathway by 2050. So the science is crystal clear about global warming and climate change. So it is changing everyone's life all around the world. And we are all responsible for the future to find feasible solution to global warming problem to minimize greenhouse gas effect, especially CO2 emission from energy sector with minimum social cost. I'm sure at least everyone in energy market has heard about net zero by 2050. In 2021, US rejoined the Paris Agreement and set an ambitious, nationally determined contribution to reduce net greenhouse gas emissions by 2030 and launched the Global Methane Pledge. The International Energy Agency released the first comprehensive energy roadmap to reach net zero emissions. It was published in May 2021, and it was a turning point for the energy market and explained what would need to happen in the global energy sector in the decades ahead to limit global warming to 1.5 degree compared to pre-industrial levels. And there's only 50% chance to reach it. So this is the important point we have to consider when we talk about net zero. This ambitious goal counts on 7 key pillars of decarbonization: energy efficiency, behavioral changes, electrification, renewables, hydrogen and hydrogen-based fuels, bioenergy, and carbon capture. To reach net zero emission, all available technologies and emission reduction options should be used. And it's clear that new technologies will play significant role in energy transition and net zero. We also need universal international cooperation. So all countries should contribute to net zero. An orderly transition is also required to reach net zero. So we cannot cut fossil fuels from the market immediately. The question I hear a lot is if the 2050 net zero goal is achievable or not. Actually, since 2021, many changes have taken place. And unfortunately, energy sector's carbon dioxide emission have continued to rise, reaching a new record in 2022. The summer of 2023 was Earth's hottest since global records began in 1880. The months of June, July, and August combined were warmer than any other summer in NASA's record, and 2.1 degree warmer than any average summer between 1951 and 1980. Global carbon dioxide emissions from energy sector reached a new record in 2022, 37 billion tons. It's 1% above the pre-pandemic level. These are not good news. Obviously, the world is way behind, and 1.5 degree warming limit is at risk. In the UN Climate Summit in COP28, officially acknowledged that fossil fuels are the root cause for climate change, and countries agreed to triple renewable energy capacity and double the global rate of energy efficiency by 2030. My next slide is about US long-term strategy. So let's see what's going on in the United States about net zero. The long-term strategy of the United States to specify pathway to net zero by 2050, published on November 2021, and it represents the steps to reach goal of net zero emissions no later than 2050 to keep 1.5 degree on global temperature rise. The United States is simultaneously pursuing multiple climate mitigation goals with multiple pathways for the American economy. And all pathways start with delivering on our nationally determined contribution in 2030. This will put United States firmly on track to reach net zero by 2050. In this graph, you see the goals in different colors. Green dot lines, line shows by 2030, goal is up to 52% emission reduction below 2005 levels, covering all sectors and all gases. By 2035, the goal is 100% carbon pollution-free electricity. And the red dot line shows the goal for net zero emissions no later than 2050. Some states have already established targets to zero out emissions from all sectors of the economy, some that are more aggressive than the federal government. And some states such as California has 2045 target to reach net zero emission. And 80% of the US representative pathway to net zero is based on transforming energy sector. It is based on increasing energy efficiency, decarbonizing electricity, and using fossil fuels with carbon capture. It's still in the picture. And energy transition with hydrogen and low carbon fuels. And heat transfer will play a significant role in all of these stages. I'd like to talk about hydrogen a little more here, because hydrogen plays significant role in US strategy to reach net zero by 2050. The US National Clean Hydrogen Strategy and Roadmap has been published by Department of Energy based on 3 key strategies. First, targeting strategic high-impact uses for clean hydrogen. This will ensure that clean hydrogen will be used in the highest value application, where limited decarbonization alternatives can happen. The second strategy is to reduce the cost of clean hydrogen. So we know the cost of hydrogen must be reduced significantly. US clean hydrogen strategy focused to reduce hydrogen production cost to $2 per kilogram by 2026 and $1 per kilogram by 2031. And also delivery and dispensing costs to $2 per kilogram by 2030. So this is called the hydrogen shot. This is called hydrogen shot. It is the target is to reach $1 hydrogen cost per 1 kilogram in 1 decade. That is called 111. And it will impact a wide range of end users. If the US economy market can reach the ambitious goal of hydrogen shot, hydrogen can be used for all sectors from transportation to power generation, which would create very high demand in the US and global market. The last strategy is to focus on regional networks. Last year, 7 regions have been introduced as hydrogen hubs in the United States, with focus on hydrogen production from natural gas and biofuel with carbon capture, and also electrolysis with renewable or clean electricity resources. Based on several models and analysis for the United States, clean hydrogen production will be increased from nearly 0 today to 10 million metric ton per year by 2030, and 20 million metric ton per year by 2040, and 50 million metric ton per year by 2050. So by achieving a 5-fold increase in hydrogen production by 2050, the total greenhouse gas emissions in the United States could decrease by approximately 10% relative to 2005 levels when all hydrogen is cleanly produced. But there's a question here. What is clean hydrogen? We know hydrogen is a clean fuel and only produce water when it is burned in fuel cells, but it doesn't mean hydrogen production and transportation to end user is a clean process. Using color code for hydrogen production is common way to specify if it is clean. Production such as blue hydrogen from fossil fuels with carbon capture, or green hydrogen from water electrolysis process with renewable electricity. But clean hydrogen production standard by Department of Energy has established a target for well-to-gate life cycle greenhouse gas emissions. So during hydrogen production, the greenhouse gas emissions should be less than 4 kilogram CO2 production for 1 kilogram of hydrogen production during a taxable year. This is what we call clean hydrogen, so regardless of the color code. So to see if hydrogen production is clean or not, we need to include all emissions, including fugitive emissions from upstream and delivery to hydrogen production facility and process. We also need to consider greenhouse gases from the electricity and also any carbon capture process and sequestration, and any other emissions generated during hydrogen production. So the other greenhouse gases and fugitive emissions, such as methane and NO2, should be considered in the model when we are evaluating clean hydrogen production. So how we consider them in the model by using equivalent global warming potential for each greenhouse gases to calculate equivalent CO2. So I have a slide here that may surprise you. So it shows hydrogen can be produced through various methods, and emissions intensity of each of these pathways depends on some variables such as carbon capture, fugitive emissions, and the use of clean electricity. So let's compare carbon intensity for different hydrogen production methods in the US current market. This figure wells to gate carbon intensity of hydrogen production from steam methane reforming and electrolysis based on Department of Energy's model. 95% of hydrogen in the US is produced through SMR without carbon capture, and less than 5% includes carbon capture. Electrolysis from grid is less than 1%, and electrolysis from renewable is also less than 1% now. Biomass and pyrolysis is less than 1%, but it has low carbon intensity. So the carbon intensity of well-to-gate emissions for electrolysis with current US electricity and grid goes up to 2 times higher than SMR without carbon capture. That is interesting. So water electrolysis with US grid is much more pollutant than steam methane reforming from natural gas. And it shows that how US grid is pollutant now. However, based on US long-term strategy, US should reach 100% carbon pollution-free electricity by 2035. So hopefully carbon intensity for a water electrolyzing will drop to 0 when electricity supply is 100% CO2 free from renewables or from fossil fuels with carbon capture. But there's still another issue that we have to solve, and that's water supply for water electrolysis. So this is another issue we need to consider when we talk about net zero. And at the end, I want to see how energy consumption has been changing in the US during the years. I have 2 slides here to compare. Energy consumption in 2022, and I compare it with pre-COVID in 2018. In 2022, the energy combustion was 100.3 quads, and in 2018, it was 101.2 quads. So I don't see significant change in the energy consumption. It seems that slightly decreased, but that's not significant. Comparing to 2005 with recent years, it shows consumption of energy with natural gas and renewable resources has been increased. So it means we consume more clean energy in the US comparing to 2005. And I want to compare CO2 level in the US. Let's look at CO2 emission from energy sector. Carbon dioxide from energy sector has been decreased about 5% comparing to 2018 pre-COVID. And from if we look at this graph, CO2 from electricity generation has been decreased about 13%. And it is because of increasing renewable electricity production in the US. Comparing 2022 with 2005, CO2 level has been decreased about 17%. So we see for the same energy consumption level from the previous page, we could reduce CO2 emissions in the US. And that's a good news for us. The new technologies in the US help renewable energy costs to be competitive with fossil fuels in long term. And we see the result in the US now. So up to 2025, US energy markets needs to reach about 26 to 28% CO2 reduction compared to 2005. And it seems that it can be achievable since we already reduced up to 17% CO2 in the US market. This is the last slide I have. I think I've covered everything. It was my favorite topic. I like to talk about hydrogen. It's very hot topic now in the market. And I really appreciate time and opportunity. And I'll take any question.
Thank you, Naomi. You can stop sharing your screen now,
Sure.
and we'll, I don't see any questions, but Becca, let me know if there are questions that I missed. I am excited. It does sound like there is a challenge, but the exciting part is that we are able, because we have these technologies and we're working on it together. I always love when it's water and energy. Those industries that we have to talk to each other, they're all combined together. And so I know there's definitely some of the water industry listening in. And so Naomi, if somebody wanted to get in touch with you, how do you want them to reach out to you?
You can connect me through LinkedIn, send me text. I will immediately reply. I check my LinkedIn every day, and you also can shoot me email. I check
Awesome.
LinkedIn.
And so Ahmed asked, only 50% can be actually achieved of net zero. I guess he's asking, can more of?
50% chance. This is based on the current technologies, but we count on the new technologies in the US and also in global level. So we hope to increase the chance with having the new technologies in the market when the new technologies are commercialized, because there are lots of new startups and new technologies, but all of them cannot be commercialized. So let's see what will happen after 2030.
Yeah, I think that getting the cost down, like you were saying, that will help people want to use that and kind of enter the market too, right? It'll be more accessible for more people. It's very interesting and full of information that we need to know, Naomi. So thank you for that. And I do love your passion for sustainability. You have spoken at the EPIC event, so the Empowering Pumps and Industry Conference last November. And you're a great role model for this sustainability in general, because it does cut across, energy sectors and people. And so always love hearing you. Thank you so much.
Thank you, Charlie.